Okay, I'm just going to do a review of all the transformations of functions and hopefully get a better understanding of the A, the H, and the K. So here we go. So far up to this point, we've primarily worked with quadratic function. The parent is y equals x squared. And what we did is we wrote it in vertex form, which has us including both an A, an H, and a K. And it's going to be important for you to understand the impact of each of these three because we can actually convert all of this to all the different other parent functions. So like the cubic function, y equals x cubed, but it could actually be rewritten in the same form. A times x minus h quantity cubed plus k. We could do the same thing with linear absolute value. Y equals a times the absolute value, x minus h quantity plus k. Same with radical. We can do the same thing. And rational functions. In all of them, you'll notice they all have the a, and the a is written as a coefficient on the outside multiplied. They all have the h. H is on the inside of some sort of grouping symbol, and they all have the k on the outside being either added or subtracted. So, when we look at the one we were working with in the quadratic in vertex form, we saw the k. What we learned was it shifts the graphs vertically, some mnemonic device. Notice it's a number that's either added or subtracted on the outside of the grouping symbol. So that's what's critical. It's on the outside. The mnemonic device was this. You are allowed to jump up and down when you are on the outside of the house. To help you see it's what's on the outside is what goes up and down. Now we transfer to the K. We learn that the K shifts the graphs vertically up and down. Again, now this is a number that's added or subtracted on the inside. So that's what's critical. Something's being added or subtracted either on the outside or the inside. Some mnemonic devices. Because it's on the inside of this grouping symbol, grouping symbols open on the left and close on the right to emphasize left and right movement. Next mnemonic device is this. If your mom sees you running in the house, she says, don't do that. You see what I mean by this mnemonic device. Here's an example. I've got stuff on the inside. You see the -5, which makes you think you should go left, but you don't do that. You actually go to the right. Another example, again on the inside. You see the +8, the +8. You might think you would go right 8, but you don't do that. You actually go 8 units to the left. All right, let's work with the A. The A causes the graph to either reflect, compress, or stretch. You want to consider the A in two parts, meaning this. If you considered, say, plus or minus A, meaning I'm focusing in on just the sign first. So that's one part. That part of the A helps determine if there will be any reflection. Obviously, if A is negative, the graph will reflect about the x-axis. If it's positive, there obviously won't be any reflecting. If we just focus in on the A now, if A is either greater than 1, so if it's just greater than 1, there will be a stretch. And if A is between 0 and 1, the graph will compress. Notice what I did not say. I did not say A is less than 1. Yes, we have greater than 1 here, but here it's not less than 1. It's between 0 and 1. So let's look at some situations. So here's some examples specifically with just the A. Here, y equals 3x squared. My A is 3. Because A is greater than 1, there's a stretch. Different one, y equals negative 7x squared. Right here, A is negative 7. Break it into two parts. The A is negative, which means there will be a reflection. And because 7 is greater than 1, there's a stretch. So again, in that example, I saw the A as two separate numbers or two separate entities. Y equals 0.6x squared. Right now, A is 0.6. Well, because 0.6 falls between 0 and 1, that means there's a compression. Next one. Here, A is negative 0.2. Break it into two parts. The A is negative, which means there is a reflection. 0.2 falls between 0 and 1, and there's also a compression. So there's two things that occurred in that graph. Y is equal to 2/5 x squared. Well, right now, A is 2/5. It's positive, so no reflection. Because 2/5 falls between 0 and 1, there's a compression. Y equals negative 3/8 x squared. A is negative 3/8. So in two parts, the A is negative, which means there will be a reflection. 3/8 falls between 0 and 1, which means there's a compression. A couple more examples. Y equals 9/4 x squared. Right now, A is 9/4. 9/4 is greater than 1. So therefore, a stretch. And the last one. A is negative 7/2. The A is negative, which means there is a reflection. And because 7/2 is greater than 1, there's also a stretch. Okay, so we'll kind of put it all together, look at a few examples. In this problem here, our A is negative 6, the H is negative 3, and the K is negative 4. Now, technically, the H is 3, but it looks like negative 3. So, because it's negative, there's a reflection. The 6 tells us it's a stretch because 6 is bigger than 1. When we look at the H shifts 3 units to the right, again because it's on the inside. 3 units to the right. And the negative 4 tells us 4 units down. So we've got 4 different transformations in this one graph. Next one. Here, our A is a half, our H is positive 5, and the K is 1. No reflection here. So because the 1/2 is between 0 and 1, there's a compression. The 5 tells us we're going to shift left 5 units, and the 1 tells us up 1. Next one, our A is negative 3 and 5/9. Technically, there is no H. H is 0, and K is 8. Okay, there's no H because there's no parentheses. All right, the A is negative, which lets us know the reflection. That 5 and 3/9 is greater than 1. That's why it's a stretch. Because the H is 0, there is no horizontal shift. So you don't have to have every transformation in every problem. And because the K is 8, that means we're shifting up 8. One last example. All right, the A is negative 0.32, the H is negative 6, and the K, there is no K. There is no number being added or subtracted on the outside. So the negative lets us know we're reflecting. The 0.32 is between 0 and 1, compression. H tells us we're going to go to the right 6 units, and there is no vertical shift. So now when I look at these examples in a graph form, when I look at my original parent, the parent looks like it went down 2 units, and it looked like it went to the right 4 units, and it also reflected, and it appears to be some sort of compression. It's gotten kind of flatter or fatter, however way you want to look at it. So we're supposed to write the equation in this form, vertex form. So we need to find numbers for the A, the H, and the K. Well, the 2 units down tells us to subtract 2 on the outside because we can jump up and down when we're outside the house. The 4 units to the right, because we're inside, Mama says, no, you can't run. So you don't do that. So instead of to the right plus 4, it's minus 4. The reflection, that just lets us know that the A is going to be negative, and that compression just tells us that number just simply needs to be between 0 and 1. So I'll look at a graph and actually play with it. All right, so here's the one that was there. And we said It reflected, so there's the negative. We said it was going to go 4 to the right and 2 down. And that's what we've got so far. And we said because it was a compression, A needed to be a number between 0 and 1. So I'll just test some numbers. I'll just put 0.5 and see what 0.5 did. It made it get fatter, but it's not fat enough. So I just keep testing. So there's no specific way of finding this. It's really just guess and check. 0.6 didn't work. 0.7 didn't work. I'm going the wrong way. 0.4. Not enough. 0.3. It's getting closer. 0.2. 0.1. There we go. So again, it is purely guess and check, but my constraints are the number had to be between 0 and 1. All right, let's try one more example. Okay, so in this situation, looks like the graph went up 4 units because each little tick mark is 2 steps. It looks like it went to the left 6 units. It definitely reflected, and it stretched. Now again, stretching. If you stretched, say, a piece of candy, it tends to get skinnier. So it looks like the picture did get skinnier. That's what lets me know it is a stretch. All right. So here's the form we need to write it in. So we need to determine the A, the H, and the K. Well, 4 units up on the outside, plus 4. 6 units left on the inside, that's going to be plus 6. Again, the opposite. It reflects about the x-axis, so guaranteed the A is negative. And because it's a stretch, that means that number just has to be larger than 1. So let's test it out. All I got to do is make it larger than 1. So there's our picture. We say we're going to go 6 to the left, 4 up, and reflect. And that's what we got. So now we just need to make this blue one skinnier. So that A just needs to be larger than 1. Let's try 3. Now it's getting skinnier, but 3 is not large enough. 4, not large enough. 5, and again, all I'm just trying to show is all I'm doing is testing. But the numbers just have to be. So there's 7, there's 8. As long as it was larger than 1. Let's leave this. Bad. So hopefully this adds some better understanding to these different transformations. If you have any questions, go ahead and pose them.